then, on to Mike's Design by Nature series. Last week he told us how the back end of beetles has revolutionised the world of fire extinguishers.
Yes, tonight he's trying to make us see how an insect smaller than a pinhead is transforming the world of night vision.
Frontline combat soldiers face constant danger, which increases massively at night. So back in the 1960s, modern night vision scopes and goggles were invented. But even the best ones still give a limited view of the world and are slightly cumbersome, which frankly isn't great. In daytime, we have around 170 degrees of vision. However, these goggles are restricted to just 30, meaning the enemy could take us unawares. Oh. But things are about to change, thanks to a tiny insect. At BAE Systems in Chelmsford, scientists have been spying on nature to improve the design of night vision with a wider view and lighter equipment. And in a room of high-tech gadgets that would make James Bond salivate, I've come to meet a real-life Q, Dr. Alex Parfitt. So, Alex, here we are, surrounded by these gizmos and this high-end technology, but I'm a biologist, and unless I'm mistaken, that's the head of a fly, isn't it?
Yes, I'm also a biologist, and what we've been looking at is biology to give us answers to our engineering problems. And what we've been looking at is this very small parasite of a wasp.
And this parasite is Xenos pecci, a tiny insect that spends most of its life inside the body of another tiny insect, the northern paper wasp. But it's the way it sees that has inspired Alex.
What we've really been looking at is the optics of this. So how does the eye work of this very simple parasite? Really with an aim of being able to produce a camera system that gives us very wide field of view, but at low light levels, which is what biology has solved and we're looking to do for our soldiers.
The way insects see is quite amazing. Grouped together on each eye are individual lenses, which point in slightly different directions, giving them an incredibly wide view of the world and allowing many to see better in the dark. Most insects have hundreds of these lenses, but Xenos pecci does the same job with fewer. And using that principle, Alex and his team have come up with one of the smallest multi-lens cameras in the world.
This prototype has 9 different lenses in there, so that's less than we see within the insect, but it still gives us that very wide field of view. What the 9 lenses do is project that image onto a flat camera beneath it.
But it's not that simple. With all those lenses working, some of the pictures are naturally upside down and some back to front. So the scientists need to sort the images out, just like Xenos pecci does.
The insect actually uses 75% of its brain to process these images and rearrange them. What we do is we take this raw data and use a very simple piece of software to rearrange those, smooth them together, and then present them.
Whilst that's very clever, I still don't understand why you don't, for example, use a fisheye lens. That's huge and got a massive field of view.
The problem you get with fisheye lenses is you get lots of distortions within it. But by having 9 separate lenses, it's almost like having 9 separate eyes on your head. So imagine having 9 eyes on stalks and stitching all those images together, and that's what you get by having this system.
Although this camera is only a prototype, it seemed only right and proper to test it in a one-show manner. Well, there we go. The technology's working. I can see via the camera on my helmet. There's the camera crew. But the best thing of all is the field of view is astonishing. They are so much better than those field goggles I used. I can see the enemy coming. It's astonishing to think this clever little piece of kit could save a soldier's life in the future. And it's not just military uses. It could be used in security systems, shops, and CCTV, all inspired by an insect 4 millimeters long. Astonishing.
And Mike is here in normal vision. Perfect.